Right now, if you get too hot, you know exactly what to do. You find shade, you grab water, you turn on the AC and stand in front of it for an uncomfortable amount of time, pretending you're not doing exactly what you're doing. And it works. You cool down, you move on, you forget about it. But here's the thing, that instinct, that immediate, almost panicked response to overheating is not modern. It is not learned. It is one of the oldest survival programs running inside your body, and it has been running, largely unchanged, for nearly 2 million years. Because long before there was shade to find, or water to grab, there was a primate standing in the middle of an African savanna, at noon, in full sun, with no shelter, no river nearby, and something large and fast that needed to be chased down and killed before dinner could happen. No tools sharp enough to matter yet, no fire, no plan B, just the sun, the heat, and a body that had to figure something out or die trying. What that body figured out is one of the most underrated survival stories in the history of our species, and the solution it landed on was so effective, so precise, so completely counterintuitive that it didn't just keep us alive, it arguably made us the most dominant predator on the planet, not because we were the strongest, not because we were the fastest, but because of how we handled being hot. Let's start with the problem. The African savanna, where Homo erectus and later early Homo sapiens spent the majority of their evolutionary history, is not a forgiving environment at noon. Ground temperatures can exceed 70 degrees Celsius. Air temperatures regularly hit 40 to 45. There is very little natural shade on open grassland, and the animals that early humans were trying to hunt, the ones with the meat and the calories that kept everything running, were faster than us, by a significant margin. A lion can hit 80 kilometers per hour, a wildebeest can sustain 60, an early human, even a well-built one, tops out around 30 to 35. In a straight sprint, we lose that race almost every time. So, the question that puzzled evolutionary biologists for decades was this: how were early humans successfully hunting large animals with inferior speed and primitive weapons on open terrain in brutal heat? What was the actual advantage? The answer came from a combination of two things, one that happened to our skin and one that happened to our relationship with time. First, the skin. Go back to what we talked about with sweat glands. Humans have between 2 and 4 million eccrine sweat glands distributed across almost the entire body surface. That number sounds like a fun fact. It is actually an evolutionary arms race written directly into your skin. Most mammals sweat primarily through their paws or rely on panting to regulate temperature. Dogs pant. Horses sweat, but far less efficiently than we do, and their fur traps heat against the body. Big cats overheat within minutes of sustained running. Their internal temperature spikes fast, their muscles start failing, and they have to stop. We don't stop. A 2019 study published in the journal Temperature found that a fit human running in hot conditions can dissipate heat at a rate that keeps core body temperature stable for hours in conditions that would incapacitate most large mammals within 20 minutes. We are not just good at sweating, we are, in purely biological terms, the most thermally efficient endurance machine evolution has ever produced, and we are almost certainly the only animal on the planet that gets better at handling heat the more we're exposed to it. Heat acclimatization in humans is a real, measurable process. Over 10 to 14 days of heat exposure, your plasma volume increases, your sweat response activates faster, and your cardiovascular system adapts to pump blood more efficiently to the skin's surface. Your body literally rewires itself to handle the heat better. No other large mammal does this to the same degree, which brings us to the second part of the answer: persistence hunting. In 1984, a biologist named David Carrier published a paper arguing that early humans were persistence hunters. The idea was straightforward and almost difficult to believe when you first hear it. Early humans didn't ambush prey. They didn't rely on a single explosive sprint. They followed prey, continuously, at a steady jog, across open terrain, in the middle of the day, in full sun, for hours. The prey would run, easily outpacing the humans at first. Then it would stop, look back, decide the threat was gone, and begin to recover. Then, the humans would appear on the horizon again, still coming, still moving, at the same pace. The prey would run again, overheat faster than the humans tracking it, stop again. And this would repeat, sometimes for 3, 4, 5 hours, across distances of up to 35 kilometers, until the animal's core temperature was so elevated, its muscles so depleted, that it simply could not run anymore, and the hunters would walk up to it, not sprint. Walk, and this isn't theory, it has living evidence. The San people of the Kalahari still practice persistence hunting today. Researcher Louis Liebenberg documented a hunter named Karoha track and run down a kudu in 39-degree heat over several hours. Karoha was wearing sandals. The kudu weighed 10 times what he did. Karoha won. The San aren't doing this with any special biology, they're doing it with knowledge, reading tracks at a run. predicting direction from a smudge in the dust, recognizing the exact moment an animal begins to overheat, a wobble in the gait, shorter strides, irregular spacing. They know the animal is more afraid of the sun than they are, and that knowledge is ancient. The anatomy required for persistence hunting, long legs, arched foot, the nuchal ligament stabilizing the head mid-run, short toes built for propulsion, all of it was locked in roughly 1.8 million years ago. We weren't just capable of this. We were built for it, specifically and precisely. But heat survival wasn't only physical, it was cognitive. Water, finding it, remembering it, knowing when it would return. Early humans developed mental maps of water sources across territories spanning hundreds of square kilometers, including sources that only appeared seasonally. They didn't just know where water was, they knew when it would be there. That's not instinct. That's planning. That's memory operating across time in a way most animals simply cannot manage. This is not a small cognitive feat. It requires spatial memory, temporal reasoning, and the ability to plan across time in a way that most animals simply cannot. Elephants are the closest comparison. They're known to navigate toward water sources during droughts using remembered routes from years earlier. But early humans were doing this while also tracking prey, managing group dynamics, making tools, and communicating complex information about all of the above to each other. And then there was shade. Not finding it. Building it. The earliest evidence of deliberate shelter construction dates to roughly 1.8 million years ago in Olduvai Gorge in Tanzania. Simple windbreaks and sun shelters, arrangements of branches and stones that created shadow and reduced wind. Nothing elaborate, but deliberate. Chosen placement, chosen materials, chosen timing. Someone looked at the position of the sun and decided where the shade would be at the hottest part of the day and built toward that calculation. That is planning. That is abstract thought applied to thermal survival. By 400,000 years ago, the evidence for shelter becomes significantly more sophisticated. A site in Terre Amata in southern France shows evidence of constructed huts. Wooden posts driven into the ground in oval patterns with a central hearth. The orientation of the structures suggests awareness of prevailing wind direction. These weren't just roofs, they were climate management, passive cooling, and heating built from materials that left almost no trace, and food. And then there was food. Nobody talks about this part. When the body is under heat stress, digestion becomes a liability. Blood flow gets pulled away from the gut and redirected to the skin for cooling. Heavy, slow-digesting foods in extreme heat are genuinely dangerous, so early humans ate accordingly. Heavier intake in the cool morning hours, light and minimal during peak heat, eating again in the evening. Hunter-gatherer groups studied in the 20th century show exactly the same pattern. They weren't counting calories. They were following a program their bodies had been running for 2 million years. So here's what that full picture looks like. Your ancestors were standing in the hottest place on Earth, running animals to exhaustion in conditions those animals couldn't survive. Building shade deliberately, tracking water across hundreds of kilometers from memory, and eating in sync with their own biology. They didn't survive the heat, they weaponized it. Every other predator retreated when the temperature climbed. Your ancestors looked at that same empty, sun-blasted landscape and saw an opening. That system is still running in you right now. The sweat appearing before you're consciously hot. The thirst arriving before dehydration sets in. The pull toward shade. You didn't learn any of that. You inherited it from people who earned it the hard way. The AC is nice, nobody's arguing otherwise, but the machine underneath it was built 2 million years ago in the African sun, and it hasn't stopped once.